Hey everyone, and thank you for joining me. Today, we are going to be going over a problem set involving both foiling and the distributive property. This will allow us to review and practice what we have learned over the last two videos. So, let's start off with the distributive property. So it tells us that if we have some variable a that's going to be multiplying on the inside, b plus c, it's going to distribute like that, and it's going to give us a times b plus a times c. And remember, this works whether we're adding or subtracting them. That doesn't make a difference there. Now, for foiling, on the other hand, remember that foiling stands for firsts, outsides, insides, and lasts. So we're going to begin by multiplying a and c as such. Then we're going to multiply a and d, then b and c, and finally b and d, which is going to give us our expanded expression found right here. Okay, so before we dive into a more complex example combining both of them, I want to start with one distributive problem and one foiling problem. So here we have a distributive problem where we have 3 on the outside and x minus 5 on the inside. So I'll give you a couple seconds to go ahead and try that. Feel free to pause the video and come back when you're ready. Okay, so what we're going to do is distribute this 3 to the inside as such. And that's going to give me 3 times x plus 3 times negative 5. Or 3x and positive times a negative is a negative, so we get 3x minus 15 as our final answer there. Now, we have a foiling example on screen, so if you'd like, you can go ahead and pause the video and come back when you're ready. Okay, so right here, we are going to foil. So obviously that means that we're going to start with our firsts, and then our outsides, followed by our insides, and finally our lasts. So this is going to give me x times 2x plus x times 3 plus negative 1 times x plus negative 1 times 3. Well, this is going to give me 2x squared plus 3x minus x minus 3, which means now we're going to go to combine our like terms. So 2x squared plus 2x minus 3 is our final answer in this case. Alright, so to start with our practice, we're going to take this expression right here, which is 3x minus 2, x plus 1. So let's start by analyzing it. First off, this 3 right here, we could use the distributive property to multiply it through to the x and to the negative 2. So as you can see, we can also foil this expression. I'll get back to that in just a minute though. So that's going to give me 3 times x plus 3 times negative 2. Put that negative 2 in brackets there. And we're going to get times x plus 1. Well, this is going to give me 3x minus 6, x plus 1. And now from this point, we can foil. So we're going to go firsts, outsides, insides, and lasts, which here that's going to give me 3x times x plus 3x times 1 plus negative 6 times x plus negative 6 times 1, or 3x squared plus 3x minus 6x minus 6. Now the final step here is to combine our like terms, which is going to give me 3x squared minus 3x minus 6 as my final answer. Now the alternative here is, instead of using our distributive property, we can begin with foiling. So that's going to give us firsts, outsides, insides, and lasts. So I'm going to continue over here with this. That's going to give me 3, and then in the brackets, x times x plus x times 1 plus negative 2 times x plus negative 2 times 1. Or 3x squared plus x minus 2x minus 2. Now, we can combine like terms inside of the brackets, which is going to give me x squared minus x minus 2. And finally, if we go back, now we can use our distributive property, because that 3 on the outside still has not been used, which means we can still use the distributive property here. And that's going to give me 3 times x squared plus 3 times negative x plus 3 times negative 2. Or 3x squared minus 3x minus 6 as the final answer. Okay, so now we have the following problem on screen. So that's 3x minus 4, x minus 6, plus 5. If you're interested, I will get you to go ahead and pause the video and come back here when you're all ready for the answer. Okay, so we're going to start by foiling. So firsts, outsides, insides, and lasts. Well, here, that's going to give me 3x squared minus 6x minus 4x plus 24 plus 5. Now, we can collect our like terms from here, which is going to give me 3x squared minus 10x plus 24 plus 5. Now, we can distribute that 3 to the inside, which is going to give me 3x squared minus 30x plus 72 plus 5, or 3x squared minus 30x plus 77 as my final answer. Okay, so now we have the following example, which I'm going to work on expanding. So let's start with the x minus 1 squared component. So that's going to give me negative 2, x minus 1, x minus 1, plus 3, x minus 4. And we can foil the x minus 1 from here. So that's going to give me negative 2, x squared minus x plus 1 plus 3 x minus 4, which is going to give me negative 2 x squared minus 2x plus 1 plus 3 x minus 4. Now, from this point, we can distribute into both expressions. So that's going to distribute to all terms there. 3 is going to distribute to both of its terms, which will give negative 2x squared plus 4x minus 2 plus 3x minus 12. Or, once we combine our like terms, negative 2x squared plus 7x minus 14 as our final answer. Okay, so I'll give you the chance to pause the video here and try the following 2 examples, then come back here when you're all ready. Okay, so let's start with the expression on the left. So the first step is going to be to FOIL this. So we're going to multiply firsts, outsides, insides, and lasts. Well, here that's going to give me x squared minus 5x plus x minus 5 minus 6. I can collect my like terms on the inside, which is going to give me 3x squared minus 4x minus 5 minus 6. Now I can go ahead and distribute that 3 to the inside. So that's going to give me 3x squared minus 12x minus 15 minus 6. And now for my final collection of like terms, that's going to give me 3x squared minus 12x minus 21 as the final answer. Now, to continue with the example on the right, we're also going to start by foiling. So that's going to give me 4x squared plus 7x minus 6x minus 42 minus 5. Now I can collect my like terms on the inside. So it's going to be 4x squared plus x minus 42 minus 5. Now this 4, again, can distribute to the inside, which is going to give me 4x squared plus 4x minus 168 minus 5, or as my final answer, 4x squared plus 4x minus 173. Okay, so I wanted to end off with this last example here, and it's going to follow a very similar process to the last few problems that we have solved. So we're going to start by converting that x plus 2 squared into two distinct sets of brackets, just to make it easier to read. X plus 2 minus 17. So from here, we can FOIL the sets of brackets, which is going to give me 3x squared plus 2x plus 2x plus 4 minus 17. Now, collecting like terms on the inside is going to give me 3x squared plus 4x plus 4 minus 17. Or if I proceed to distribute the 3 to the inside, 3x squared plus 12x plus 12 minus 17. Now, collecting those final like terms, the 12 and the negative 17, we get 3x squared plus 12x minus 5 as our answer. Okay, so thank you very much for joining me, and I hope you found this valuable.